In 2019, a researcher named Stijn van den Hoven published a 35-page paper on the academic publishing platform Academia. He had spent years studying the Pyramid of Menkaure, the smallest of the 3 great pyramids on the Giza plateau, and he noticed something that apparently nobody else had bothered to document. On the eastern face of the pyramid, a set of polished granite blocks had been finished with the exact same precision as the blocks surrounding the known northern entrance. That polishing technique exists nowhere else on the entire structure, just those 2 locations. Van den Hoven argued this meant one thing: there had to be a second entrance hidden behind those eastern blocks. Nobody in mainstream Egyptology paid attention. No citations, no peer review, no response at all. 6 years later, a team of 20 scientists from 5 countries aimed 3 different scanning technologies at those exact blocks on the eastern face of the Pyramid of Menkaure. Ground-penetrating radar, electrical resistivity tomography, ultrasonic testing. They fused the data from all 3 systems into a single composite image. And behind those polished granite blocks, they found 2 air-filled cavities, exactly where Van den Hoven said they would be. But here is the part that keeps researchers up at night. The team that confirmed these cavities cannot determine how deep they go. The scanning equipment reached its limit. Whatever those voids connect to remains invisible. And that was only the beginning. The peer-reviewed confirmation was published on April the 25th, 2025, in NDT&E International, an Elsevier journal specializing in non-destructive testing. The paper described 2 distinct anomalies. The first, labeled A1, measures approximately 1.5 meters wide by 1 meter high, and begins just 4.5 feet behind the granite facade. It sits directly behind what the researchers call a high-resistive trapezoidal granite block. The second anomaly, A2, is slightly smaller at roughly 0.9 by 0.7 meters. Starting 3.5 feet deep, numerical simulations run by the team ruled out the possibility that these voids were natural cracks or random construction irregularities. These are deliberate spaces. Christian Gross, professor of non-destructive testing at the Technical University of Munich and one of the lead researchers, stated that the hypothesis of another entrance is very plausible and that their results bring us a significant step closer to confirmation. He added that such precise determination of air-filled voids is only possible by combining all the measurement data from multiple technologies simultaneously. Peter der Manuelian, an Egyptologist at Harvard who was not involved in the study, offered a simpler observation. This shows we still have more to learn about the pyramids at Giza. The recommended next step, according to the paper, is Muon imaging or endoscopy. In other words, the scientists want to either send subatomic particles through the stone to map what lies beyond, or physically insert a camera. Neither has happened yet. So who was this pharaoh whose pyramid just revealed a secret entrance 4,500 years after his death? Menkaure ruled during the 4th dynasty of Egypt's Old Kingdom, approximately 2532 to 2503 BCE. His name in ancient Egyptian translates roughly to eternal, like the souls of Ra. He was the son of Khafra and the grandson of Khufu, the man who built the Great Pyramid. By the standards of his dynasty, Menkaure was the quiet one. His pyramid stands just 65.5 meters tall, less than half the height of his grandfather's Colossus at 146 meters. But Menkaure had ambitions that none of his predecessors shared. He ordered his pyramid clad in red granite quarried in Aswan, 800 kilometers up the Nile. No pharaoh before him had attempted this. The logistics alone were staggering. Each block had to be cut from the quarry, loaded onto barges, floated hundreds of miles downstream, hauled across the desert to Giza, and then hoisted into position and polished smooth. Of the 16 to 18 courses of granite cladding he planned, only 7 were ever finished. The upper courses remain rough-cut, their surfaces still bearing the marks of tools that were meant to return. And those unfinished blocks tell us something remarkable about how the pyramids were actually built. The cladding stones were placed first, working from the bottom up, and then polished from the top down. We know this because the lower 7 courses at Menkaure are polished smooth, while the upper courses above them are rough. The builders set every stone in position, and then worked their way downward with grinding tools, turning raw granite into a gleaming surface that would have reflected sunlight across the Giza plateau. Death interrupted the process. The polishing crews simply stopped, and the line between finished and unfinished stone is still visible today, frozen mid-construction after 45 centuries. Menkaure died before the work was done. His successor, Shepseskaf, completed the temple complex, but he used cheap mud brick instead of stone. And he never built his own pyramid at all. 3 generations of pyramid building had apparently exhausted the will and the resources of an entire kingdom. The Greek historian Herodotus, writing roughly 2,000 years after Menkaure's death, based on accounts from Egyptian priests, painted him as a just and beloved ruler. He opened the temples and gave liberty to the people after the tyranny of Khufu and Khafra, according to those accounts. But the priests also told Herodotus a darker story. An oracle at the temple of Buto had predicted that Menkaure had only 6 years left to live. The pharaoh protested. Why should a just king die young while tyrants grow old? The oracle's answer was cold. Egypt had been destined to suffer for 150 years. Menkaure's goodness had disrupted the divine plan. His reward for mercy was an early death. According to the legend, Menkaure responded by ordering torches lit every night, refusing to sleep, and feasting continuously, attempting to compress 12 years of living into 6. Whether any of that is historically accurate is debatable. What is not debatable is what happened to his sarcophagus. On August 1, 1837, Colonel Richard William Howard Weiss and his engineer John Shea Perring reached the burial chamber deep inside the pyramid. They found a basalt sarcophagus decorated with a serach motif, the distinctive palace facade pattern of Egyptian royalty. Weiss described it as beautiful, black, and rich in detail, with a bold projecting cornice. Inside, they found the bones of a young woman, clearly not Menkaure. A separate wooden coffin bearing Menkaure's name was also recovered, but radiocarbon dating later placed it between 1212 BCE and 846 BCE, more than 1,000 years too late. The British Museum authorized £15 for transport of the sarcophagus. Think about that for a moment. The burial vessel of one of Egypt's great pharaohs, carved from solid basalt, decorated with royal insignia, and the institution responsible for its preservation spent £15 on shipping. By July 1838, the sarcophagus was loaded onto the Beatrice, a merchant schooner captained by Richard Mayle Wichelo. Wichelo was no ordinary merchant sailor. He had served on HMS Britannia at the Battle of Trafalgar in 1805 and earned the Trafalgar Medal. He had watched Nelson die on that ship. 33 years later, he was ferrying a pharaoh's coffin across the same Mediterranean waters. The Beatrice departed Alexandria on September 20, 1838, made a brief stop in Malta on October 13th, and then sailed west toward Liverpool. She was never heard from again. Lloyd's Loss and Casualty book, dated January 31, 1839, recorded the final entry. The Beatrice Wichelo sailed from Alexandria on September 20th and from Malta on October 13th for Liverpool, and has not since been heard of. Wreckage was later spotted near Cartagena on the southeastern coast of Spain. The basalt sarcophagus of Menkaure, along with Captain Wicello and approximately 20 crew members, sank somewhere in the western Mediterranean. The sarcophagus lid, shipped separately on a different vessel, arrived safely in London and sits in the British Museum to this day. In 2008, a joint Spanish-Egyptian underwater search operation attempted to locate the wreck. The effort was abandoned around 2012. The jurisdictional nightmare of a British ship in Spanish waters carrying an Egyptian artifact involving three nations' maritime laws and cultural heritage claims proved insurmountable. The historian Nikki Nielsen published detailed research on the Beatrice in the International Journal of Maritime History in 2024, and the primary documents from the entire saga are preserved in a dedicated online archive. The pharaoh who died too young now has his coffin on the bottom of the Mediterranean, his pyramid still hiding secrets, and an independent researcher's prediction vindicated 46 centuries after the last granite block was polished. But the scientists who scanned Menkaure did not develop their method there. They had tested it on a far bigger target first. The ScanPyramids project launched in October 2015 as one of the most ambitious archaeological technology programs ever attempted. Co-directed by Hani Helal, a Cairo University professor and former Egyptian Minister of Higher Education, and Mehdi Tayyoubi of the HIP Institute and Dassault Systems. The project brought together researchers from 6 countries: Egypt, France, Japan, Germany, Canada, and the United States. Tayyoubi captured the mission's philosophy in a single sentence: just because a mystery is 4,500 years old does not mean it cannot be solved. The central technology is Muon tomography, and understanding how it works is simpler than it sounds. Every second of every day, cosmic rays from deep space slam into the upper atmosphere of Earth at nearly the speed of light. These collisions produce cascades of secondary particles, including muons, subatomic particles roughly 200 times heavier than electrons that travel at close to light speed. Approximately 10,000 muons per square meter per minute rain down on the surface of the planet, passing through everything, including buildings, mountains, and pyramids. Here is the key. Muons penetrate solid material far better than X-rays, but they lose energy in proportion to the density of what they pass through. Dense stone absorbs and deflects muons. Open cavities let them sail straight through. By placing detectors on or inside a structure and counting the muons that arrive from different angles, scientists can build a density map, essentially a shadow image of the interior. The Great Pyramid of Khufu blocks approximately 99% of incoming muons, which means the detectors had to collect data for months to accumulate enough particles for a clear picture. 3 independent detector systems were deployed simultaneously inside and around the Great Pyramid. These included nuclear emulsion films from Nagoya University, passive silver halide plates installed for weeks inside the Queen's Chamber to record muon tracks, scintillator hodoscopes from KEIK in Japan, electronic real-time detectors using plastic scintillators, and micromegas gas detectors operated by Sébastien Procureur of the French Alternative Energies Commission, gas-filled telescopes positioned outside the pyramid and named after Nobel laureates. Roy Schwitters of the University of Texas at Austin summed up the physics elegantly. Muons are like Goldilocks. They lose enough energy to detect them, but not so much that they just get absorbed in the target. Before aiming this technology at the Great Pyramid, the team needed proof it actually worked on a structure of this scale. They chose the Bent Pyramid at Dashur, built by Khufu's father Sneferu around 2600 BCE. The Bent Pyramid earned its name because the builders changed the angle of the walls partway up, likely after discovering the original slope was too steep for the foundation to support. It is one of the best preserved pyramids in Egypt, and crucially, Its internal layout was already known, which made it the perfect test case. If the Muon detectors could accurately image the known upper chamber from the known lower chamber, the method was validated. In April 2016, nuclear emulsion plates from Nagoya University were placed in the lower chamber and left for 40 days. When recovered and analyzed, the plates contained the tracks of over 10 million individual muon particles. From those tracks, the team reconstructed an image of the upper chamber 18 meters above. The dimensions matched. The position matched. This was the first successful muon imaging of the internal structure of a pyramid in history. No unknown burial chamber was found inside the bent pyramid, but that was beside the point. The method worked. The team now had confidence to aim the technology at the most complex structure on the Giza Plateau. What happened next at the Great Pyramid would become the largest structural discovery inside Khufu's monument since the 19th century. On October 15, 2016, the ScanPyramids team announced the detection of two previously unknown cavities inside the Great Pyramid. One was at the northeast edge, and another sat behind the massive chevron blocks on the northern face. These were tantalizing hints, but the real announcement came 13 months later. On November 2, 2017, the journal Nature published a paper that sent shockwaves through archaeology and physics alike. Deep inside the Great Pyramid, above the Grand Gallery, Muon detectors had identified a massive void. That discovery became known as the ScanPyramids Big Void. It is at least 30 meters long, and it has a cross-section similar to the Grand Gallery itself. That comparison matters. The Grand Gallery is the most spectacular interior space in any pyramid ever built. A corbelled passage rising nearly 9 meters high and stretching 47 meters long. Whatever the Big Void is, it occupies a comparable volume of empty space. All three independent muon detection systems confirmed its existence at 5 sigma confidence, the gold standard used in particle physics to declare a discovery beyond reasonable doubt. 5 sigma means there is less than a 1 in 3.5 million chance that the signal is a statistical fluke. If we are keeping track, that means a void the size of a commercial aircraft fuselage has been sitting inside the largest pyramid on Earth for 4,500 years, and nobody knew it was there until subatomic particles from deep space revealed it. Like and subscribe if you want to stay updated on what scientists find next inside these pyramids. We cover the latest archaeological discoveries every week, and trust us, the next chapter in this story is already unfolding. The Big Void remains completely unexplored. Nobody has ever been inside it. Theories about its purpose range from a construction ramp proposed by Kate Spence at Cambridge, to a weight-relieving structure, to an undiscovered burial chamber. Sebastian Procureur has stated that the Muon data rules out the possibility of rubble filling the space. To detect a large excess of muons, you need a large void, he explained, and smaller stones would fill this up. Accessing the void would require some form of invasive procedure, and Egyptian authorities have firmly refused. The Egyptologist Salima Ikram put the dilemma this way: if there is something behind the Mona Lisa, would you want to wipe her clean and see what is behind her? But ScanPyramids was not finished with Khufu's pyramid. Between 2020 and 2022, the Technical University of Munich conducted ground-penetrating radar and ultrasonic scanning campaigns focused specifically on the chevron blocks above the pyramid's main entrance on the northern face. These chevron blocks are among the most recognizable features of the Great Pyramid. Enormous limestone slabs arranged in an inverted V-shape above the original entrance. They have been visible and studied for centuries, but what lay behind them had never been directly observed. The instruments detected a corridor-shaped structure. On February 24, 2023, an endoscope camera with a diameter of just 5 millimeters, thinner than a pencil, was threaded through a narrow joint behind the lower chevron blocks. The camera traveled through gaps between stones that had not shifted since the reign of Khufu. What appeared on the screen was something no human eyes had seen in 4,500 years. An empty corridor with rough-hewn stone walls, a gabled ceiling, visible tool marks left by the original builders, the actual chisel strokes of workers who had shaped this space during the Old Kingdom. An uneven floor that had never been walked on since the day the corridor was sealed. The corridor stretches approximately 9 meters in length, with a cross-section of roughly 2 by 2 meters, positioned between 17 and 23 meters above ground level, sitting just behind the northern face of the pyramid. At the far end of this corridor, illuminated by the endoscope's light for the first time in 45 centuries, sit 2 large limestone blocks. Their purpose is unknown. Nobody knows whether they are a dead end, a plug blocking further passage, or a deliberate partition separating this corridor from something larger beyond. The discovery was published simultaneously in Nature Communications on March 2, 2023, and has since accumulated over 137,000 views. Mustafa Waziri, head of Egypt's Supreme Council of Antiquities, stood beside the pyramid during the press conference and stated that the corridor may have been designed to redistribute weight above the main entrance, or around another as yet undiscovered chamber. Pay attention to those last 5 words. Another as yet undiscovered chamber. In March 2025, the same triple scan methodology used at Menkaure, combining electrical resistivity tomography, ground-penetrating radar, and ultrasonic testing with image fusion, was validated on Khufu's corridor in a paper published in Scientific Reports. That paper has already attracted over 233,000 views. This is not a collection of isolated experiments. It is a single coherent research program. The method was proven at the Bent Pyramid, deployed at Khufu, refined through image fusion, and then aimed at Menkaure. Each pyramid validated the technology for the next. So let us take stock of what we know. 2 air-filled cavities of unknown depth inside the smallest pyramid at Giza. An unexplored 30-meter void inside the largest pyramid. And a 9-meter corridor ending at 2 limestone blocks that nobody has moved. 3 separate mysteries. 1 decade-long scanning campaign. And then, on November 8, 2025, Zahi Hawass walked onto a stage and made a promise that changed the stakes entirely. The setting was the 44th Sharjah International Book Fair in the United Arab Emirates. The session was titled Secrets of the Pharaohs, hosted by Emirati interviewer Anas Bukash. Hawass, the former Secretary General of Egypt's Supreme Council of Antiquities and arguably the most famous living Egyptologist, told the audience something extraordinary. He said, "We found a 30-meter passageway inside the Pyramid of Khufu, with a door at its end. Next year, we will reveal to the world what lies behind that door." He went further. This great discovery is a new 30-meter-long passageway, detected using advanced equipment, which ends at a door that will rewrite a chapter in the history of the pharaohs. He listed the technologies involved: thermal imaging, 3-dimensional mapping, Muon radiography, and advanced robots. He also expressed hope for the discovery of the tombs of Imhotep and Nefertiti, calling a potential Imhotep find perhaps even greater than the discovery of Tutankhamun's tomb. The announcement was reported by the United Arab Emirates state news agency, WAM, the Khaleej Times, Sharjah 24, Egypt Independent, the Jerusalem Post, and Greek Reporter within days. Now this is where we need to slow down and look carefully at what was actually said, because the difference between what Hawass announced and what the peer-reviewed science supports matters enormously. Hawass described a 30-meter passageway ending at a door. The peer-reviewed literature as of March 2026 describes 3 things inside the Great Pyramid that could potentially be connected to this claim. First, the Big Void, discovered in 2017, which is at least 30 meters long, but was detected via Muon imaging and has never been directly observed, meaning nobody has confirmed it is a passageway at all. Second, the 9-meter corridor behind the chevrons, confirmed in 2023, which ends at 2 limestone blocks, not a door. Third, whatever may lie beyond those limestone blocks, which has never been imaged or explored. No published peer-reviewed paper describes a 30-meter corridor ending at a door. That specific claim exists only in Hawass's public statement at a book fair. The critical question is whether Hawass is describing the Big Void in corridor terms, which would be a loose interpretation of Muon data, or an extension of the 9-meter corridor beyond the limestone blocks that has been explored by robot and not yet published, or something entirely new from robotic missions that the public has not been told about. We do not know, and as of March 2026, we have no way to verify any of these possibilities independently. Sébastien Procureur, the French physicist who led the Micromegas detector team, has mentioned unpublished findings about the void, which he said would be released in the near future. That was months ago. Those findings have also not appeared. This is worth examining in context. Hawass has made repeated public announcements about discovering Nefertiti's tomb in 2022, 2023, 2024, and again in 2025, without publishing a final peer-reviewed confirmation. His announcements consistently occur at publicity events, book fairs, television interviews, and public lectures, not in scientific journals. This is a pattern. Generate international attention, then silence. The promised 2026 revelation of what lies behind the door has not materialized. No publication, no press conference, no official statement from the Supreme Council of Antiquities. And yet there is one more piece of this story that makes all of this harder to dismiss. Hawass himself said something in 2013 that rarely gets mentioned in these discussions. He stated publicly that he believes the real chamber of Khufu has never been found. The 3 known chambers, he argued, were designed to deceive tomb robbers. The treasures of Khufu are still hidden inside the Great Pyramid, he said. He pointed out that the king's chamber contains only an empty, lidless granite sarcophagus. No mummy was ever found inside. The conventional explanation is that ancient grave robbers stripped it bare. But the king's chamber is the only known Egyptian burial chamber positioned above the entrance. Every other burial chamber in every other pyramid sits below the entry point. That is an architectural anomaly that has never been satisfactorily explained. Now we have a void 30 meters long that nobody has entered. A corridor ending at blocks nobody has moved. A promise of a sealed door, and an Egyptologist who believes the real burial was never found. We are not making claims. We are laying out what has been published, what has been promised, and what remains unverified. The dots are there. Whether they connect is a question that only the next peer-reviewed paper can answer. But while the world waits for that paper, the scanning campaign is not standing still. A new international collaboration called SkyDep, the scintillator imaging detector for the Egyptian pyramids, is building dedicated Muon telescopes specifically designed for the Pyramid of Khafra, the middle and second largest pyramid at Giza. Khafra's pyramid has received far less scanning attention than either Khufu or Menkaure, which means it may be hiding structures that nobody has even begun to look for. The SkyDep project involves researchers from Egypt, Belgium, the United States, and Romania, and was published in the Journal of Applied Physics in July 2025. If these instruments become operational on schedule, all 3 Great Pyramids of Giza will be under advanced scanning simultaneously between 2026 and 2027, Consider what that means. For the first time in history, science will be looking inside all three monuments at the same time, using technology that did not exist a decade ago. And the pace of technological evolution in this field is staggering. The scanning campaign that began at the Bent Pyramid in 2016 with passive film plates and 10 million Muon tracks has evolved through 4 distinct technological phases. Phase 1, from 2015 to 2016, relied on passive detection using infrared thermography and nuclear emulsion films that had to be physically collected and developed like old-fashioned photographs. Phase 2, from 2016 to 2017, introduced electronic muon detectors that provided real-time data streams instead of waiting weeks for film development. Phase 3, from 2020 to 2023, combined active probing technologies, ground-penetrating radar, ultrasonic testing, and endoscopy, allowing researchers to not just detect anomalies, but physically observe them. And Phase 4, from 2025 to the present, has achieved multimodal image fusion, merging electrical resistivity, ground-penetrating radar, and ultrasonic data into composite 3-dimensional maps that resolve features invisible to any single technology alone. This is the same image fusion method that found the cavities in Menkaure. Each phase sees deeper. Each phase resolves more clearly. Each phase finds something that was not visible before. And it all started with the pyramid that everyone ignored. Menkaure, the smallest of the 3, the unfinished one. The pyramid whose sarcophagus sits on the floor of the Mediterranean, while its granite cladding still bears the marks of tools that were supposed to come back and finish the job. Every tourist who visits Giza walks past it on the way to the Great Pyramid. Every documentary crew films it as an afterthought. An independent researcher named Stijn van den Hoven said there was a second entrance hidden behind those polished eastern blocks. And for 6 years, the academic world treated his paper like it did not exist. Then 20 scientists from 5 countries confirmed he was right, and the cavities they found extend deeper than their instruments can see. The pharaoh who died before his pyramid was finished may have hidden something behind a door that has not been opened in 45 centuries. And somewhere inside the Great Pyramid his grandfather Khufu built, there is another door, or so we are told, that could rewrite the history of the pharaohs. The peer-reviewed papers are stacking up. The scanning technology is advancing faster than at any point in the history of archaeology. And all 3 pyramids at Giza are about to be transparent to science for the first time. We will be covering the results the moment they are published. If the doors open, we will be here.